Alright, number 1 says work the following on a notebook sheet of paper, give answers to 3 decimals, and we're going to look at roast turkey is taken from the oven and placed on a counter to cool. So this is going to be cooling. As you can see, our temperature is decreasing as we go throughout. Room temperature is what it's cooling to. The table shows the temperature of the turkey at various times. So our input, of course, is T for time over the 3-hour period. So if you don't know already, there are 60 minutes in an hour, 180 minutes, because we are in minutes is going to show you that 3-hour elapsed time. Use the data in the table to find what is T of 90. Our function, our position function is T of T, otherwise referred to as f of x. Our input is x, our output is f of x. Our input is t, our output is t of t. They're trying to confuse you with all these t's. If I'm looking at 90, what is my position at 90? At 90 minutes, my position is going to be 110. We're just going to use appropriate units and explain the meaning. The meaning is basically it's the position at 90 minutes. So appropriate thing, we're going to say T of 90, let me write over here, T of 90 is equal to 110 degrees Fahrenheit. Explain the meaning of my answer. That means that this roasted turkey is 110 degrees Fahrenheit at 90 minutes. And you can say that, meaning turkey is 110 degrees Fahrenheit after 90 minutes have passed. Okay? Looking at this, B says use the data in the table to find the inverse of the t function at 150. Now, this is not the derivative. Don't let this confuse you. This to the negative 1 is not f prime, or t prime in this case. This is just saying on the inverse, remember x yields y, the inverse is y yields x. So I'm not looking at this as an input of my t of t. I'm looking at 150 as my output of t of t. We learned that way back in Algebra 2 and also in pre-calc. So I need to look for a y value, because it's the inverse function, of 150. What input yields that? The input of t is the output of the inverse function. So the answer for this is going to be 30, and it'll be that 30 minutes. So you say t to the negative 1, which is the inverse function of t, the inverse of t will give me an answer of 30, coming from this input value of 150. Remember, this is knowing inverses. Okay? And I'll just quickly, if this f of x, and this is inverse of f of x, this x right here will yield a y, whereas this, basically, the input here yields an output. And over here, the output yields an input. It is backwards indeed. What is the meaning of this? This means that my degrees is 150 at 30 minutes. Alright, so between 0 and 80, must there be a time, t, when the temperature of the turkey is 125 degrees Fahrenheit. So if I'm looking at here 185 all the way to 79, well, they're saying between 0 and 180, if you have 185 and you have the 79, must there exist a 125 somewhere over here? There must exist a 25 somewhere there. And the way we do that is we're going to show this intermediate value theorem. This is a continuous function of some sort. So the intermediate value theorem has those 3 I rules. This is a continuous function because all of a sudden it didn't vaporize or go into the 4th dimension or somewhere else and disappear and then reappear, and it was 110. Alright, so we're going to say that this right here is going to be a continuous function just off what we are given from the table and the real world example. So we can say T of t is continuous, and it's continuous on 0 to 180. This is very similar to the problems that we're doing when we're doing the intermediate value theorem, only this is real world with real world application. The second one is f of a does not equal f of b. Alright, our a value comes from 0. Our f of a is 185. That's the output at 0. And it is not equal to f of b. The b value is 180. The f of b is 79. Okay? So what we're trying to do is, here's that 185, just like we did on the other problems. Here's that 79. We're basically saying let k equal this 125. So f of c is this 125, and the stipulation that must exist for your theorem to hold is this established k value must be somewhere in between here and here, which it is. So I can continue with this with the theorem, and the theorem does hold. So we're going to say let f of c, or let k, equal 125. That way we can go ahead and show that it will exist somewhere in between, and it will give us the value of x that exists in between. This 125 does exist, and it will yield a value that is in between 0 and 180. Alright, so as far as our function, we are not given a function, but we can show from the work that we have right now that it is a continuous function. We're not given an explicit function that we can solve for this c, but if we were to put this into our calculator, which that's not what you wanted to do here fully to verify, what is that regression, what is that line of best fit, whether it's quartic, cubic, quadratic, we're just going to show that it would in fact yield that answer of 125. So that's enough justification. Use the data in the table to find the approximation for what is the derivative at 75. Alright, so let's clear some of this up a little bit. We're trying to see what is the rate of change, or the slope, of all this data at 75. So if I know 75 is somewhere here, and it's 15 away from 60, also 15 away from 90, we're basically trying to find what is the slope here. Because we're doing approximate units, or where is it at? Approximation. It doesn't have to exactly equal what the function is, if it's a variegating function, if it's changing like that or whatnot. We can use the approximation. Is synonymous with the average rate of change. So all we have to do is solve for the secant, or the average rate of change between those 2 points. I have 60, 130. There's my first point. I have 90, 110. There's my second point. All I have to do is y2 minus y1 over x2 minus x1 over 90 minus 60. And we're going to get negative 20. So 110 minus 130 is negative 20. It will be over 30. And this is going to equal this negative 2/3. This right here, t prime of 75 is equal to negative 2/3. Okay? Use the data to find the approximation for what is the slope at. Approximation shows you that average rate of change, that secant that you're looking for at 75. Show the computations. Here are the computations. We used units. As far as the units go, this is the changing degrees Fahrenheit. So negative 2/3, the change is over time, over minutes. So it's changing by negative 2/3 degrees Fahrenheit for every minute. And explain the meaning, it's just saying that it's the average rate of change. It's the average rate of change between 60 minutes and 90 minutes in degrees Fahrenheit per minute.